Hello all. In this video we'll see how we'll do the RESNET OpenVINO implementation with NPU. I'm Abhishek Nandi. I'm PhD scholar with Bioinformatics AI and Industrial IoT, and I'm also Intel NPU early access developer. So as you know that neural computing is the next buzzword for the development, as we are trying to bring in or bridge the gap between the neural processing unit that helps in sharing our AI workloads for PC, and we'll see how we can do it. Okay, so what we are trying to do? So first of all, the code that you'll see is all about recognizing images efficiently using a special technique called OpenVINO. It is designed to work on neural processing unit, as we know that everything that we are trying to achieve would be on neural processing unit itself, which are like specialized brains for handling artificial intelligence tasks. So the new brand of computers that are coming in, the laptops also, it has got a special neural processing unit inbuilt, and Intel is also specialized in developing these chips attached to the CPUs, and it improves the performance. And we'll see today with RESNET that how many images that we can infer and how it utilizes the neural engine to get started with. The code is designed to work with a pre-trained image recognition system RESNET, and it optimized to run efficiently on specialized hardware. So setup, it sets up the folders to store the model and cache the data for faster processing. It initializes OpenVINO, a toolkit for making AI models run faster. Model preparation, it checks the model is already in format that works for NPU. It tells OpenVINO to get the model prepared for specific hardware. It gets the image data, then we do the image feed, like feeds the image to the model, gets the model's prediction about what's the image it is, prints out both the corrected answer of the image and also the model's prediction, so we can compare how well we are going. So let's just see it in action currently. So we would be utilizing, as you can see, like the device that I am using has a special capability of NPU, and the current utilization of NPU is 0. Just keep it on the left hand side so that you can observe if some changes are happening for it. Okay, so we kept it. Now let's open up the code. So in the code itself you'll see like I've initialized OpenVINO library as OV, brought in the torch vision models, imported torch, and also the data set. First of all, I am setting up the directory paths as model and cache. I am ensuring that the directories exist. As you know, like when you are initializing an OpenVINO library itself, the code needs to be initialized. So this particular command, that is core equal to ov.core, initializes the OpenVINO core for us, and we are setting the property for cache directory. We are making the specifics for RESNET, and we are using floating point 16 precision format for it, and we are bringing in the IR model, that is converting the RESNET model to the intermediate reference model, so that we are able to use it with the OpenVINO format. So one crux that why we are using OpenVINO is that because with the NPU structure integrated in the new OpenVINO, the versions that have come out, it's very useful for us to bring in or create applications using OpenVINO for NPU. So we are loading or converting the model first. We are converting PyTorch model to OpenVINO IR format. Then we are saving it to a precision format of FA floating point 16. The input size is 13224 and 224. As you see, we are reading the IR model and also reading the model itself. Now, as you can see, the most important part is these three lines 39, 40, 41. Where we are initializing the device to be NPU, we are selecting the model to work on NPU, and we are compiling the model on NPU itself. So it is giving all the informations for us to work on the NPU as a whole. We are loading the CIFAR10 data set that is already there. We are having the images, but one crux, or we are trying to do something very extreme levels, you can say, for an NPU, that we are trying to build in like 10,000 images. We are trying to add it to our images for reference. We have given the classes of it, like aeroplane, then automobile, bird, cat, as you can see. And after that we are doing the converting the tensor to numpy array, converting to pillow image, and then we are adding a dimension, and finally we are performing the inference part. Okay, so let's see with how we are trying, how we are getting the responses and how fast it is. I've just kept the NPU window aside. Currently it's not utilizing any factor. I open up my Anaconda prompt that has got the NPU enabled. Okay, so as you can see that the file name that we have said is NPU new one, and if I hit enter over here, you will see the changes on the NPU stack. Currently, as you see, like, it's utilizing the NPU to the fullest, and the utilization of NPU over here is 74%, and you see the changes happening. It's going through all the images that are available, and it has done the inference for us. So as you can see, like, it's very useful, and probably there were around 500 images to work with. That's why it's showing the results of 500 images. Let me check once again that if did I save it or not. I'll again try out with the 100,000 itself. Probably I didn't save it. Let's see again. That would be a double check for us, that if there are more 500 images only or not. We are running it again. Keep an eye on the NPU. The cache time is happening, and we are seeing the utilization of images for NPU, and this time around I have made it to 10,000. So let's see how much time it takes. It is currently utilizing the 44% of the utilization for NPU, and as you can see, NPU is able to take lot of workload for us. And if you are trying to achieve a goal of making applications which are AI workload oriented, and you are putting it into NPU, this probably will not crash at all. Let's see the fullest strength of it on its own. Now it is close to 3000, but I have added like 10,000 images to it, and you see like how we have utilized OpenVINO over here, and we are strengthening it with so many images put into our application. So it's close to 3000 right now. Then and the limit that we have set up is of 10,000 itself, and you can see like currently the utilization for NPU. Let's check more features for the NPU itself. Like right now it's showing the Intel AI boost, the 3D options over here, NPU activity happening. The direct X version is also shown. The graphs are shared for over here, and the utilization part. Let's see how much it has gone to. It has gone to 5,000 images, so it would come up with 10,000 images itself as a whole. So as you can see, like, it crosses the 10,000 images without breaking the barrier, and we are trying it for the first time to check the bench strength or the benchmarking